In this video, we're going to begin to talk about section R.5, which is about factoring polynomials. And so much of this video is probably going to be a review for you, or we're going to talk about something that you know in sort of a different circumstance. So hopefully this will be a smooth and easy section. So let's talk about factoring a polynomial, or what are factors of a polynomial. So that might be helpful to know. Consider the following product here. And so I have 2x plus 3 times x plus 4. And that is equal to 2x squared minus 5x minus 12. Okay? And I got the right side by distributing, specifically doing FOIL on the left-hand side. Okay? But the two polynomials on that left-hand side of the equation are called the factors of the polynomial on the right-hand side of the equation. So 2x plus 3 and x minus 4 are factors of the polynomial 2x squared minus 5x minus 12. Right? If a polynomial can't be written as the product of two other polynomials, then that polynomial is said to be prime. Okay? So when I can't split up the polynomial into smaller products, that's when the polynomial becomes prime. Okay? So when a polynomial is written as the product of prime factors, then it is said to be factored completely. Okay? And so that's what we're interested in. So we want to split up a polynomial such that we can find its factors, and not just any factors, but we want the prime factors. So we want to factor sort of all the way down until we can't go any further, is basically what that's saying. So here are a number of examples. Okay, they're all fairly simple, but the first thing that you should do when you're interested in factoring any sort of polynomial is see if there are common monomial factors, which is the second column here, that I could pull out in front. Okay, and then we have the remaining factors left over. So I go through, the book goes through a bunch of examples here. 2x plus 4, there's a common monomial factor of 2. There's a 2 common to both. And so I could pull a 2 out. So that's the common factor. Okay? And then what's left is the remaining polynomial. Okay? And so we'd have 2, the common monomial factor, times that remaining factor. And so that's a way that I can get to factored form, is just by what I would call distribute out, or distribute backwards from what we usually do. And that goes the same for every example in here. So you can look over those, make sure each of them makes sense to you, what's going on, okay, and then you can move on. Okay, so first step, try to find the common monomial term. Second step is to see if it's a special product of something. So is the polynomial that we're looking at special in some way that's going to help us solve our problem? Okay, and so we have a few formulas here. Okay, and just so you know, if this were to come up on an exam, which it is likely to, you would have or may have access to these formulas. I'm not going to expect you to memorize all of them. Okay? So we check for common factors first. Once we do that, then we look for these special polynomial structures that have easy sort of things to remember of how to factor them. Okay, so we could have a difference of 2 squares, perfect squares, a sum of 2 cubes, and a difference of 2 cubes here, as all are different, but nice ways of factoring. And so I, as an example, want to factor x cubed minus 3. Sorry, x cubed minus 1. I can't read. It's been a long week. So we have x cubed here's first, so that's going to point us towards hopefully either one of these two things. Okay, so I have x cubed minus, and so maybe I'm looking at not the sum, but now the difference. So I know I'm doing this if that a is like a cube of something. Okay, so we have x squared minus 1, and is 1 a cube of some number? The answer is yes. 1 cubed is equal to 1. 1 times 1 is equal to 1, and then you do it a third time is still equal to 1. So we do in fact have this difference of 2 cubes set up. Okay, and so to factor, we can just use this equation. Okay, and it's x minus a, and in this case a is 1, right? And then we have x squared plus ax plus a squared. Okay, so we have x squared plus ax, a is 1, so x plus a squared, a is 1, so 1. And so we have the product x minus 1 times x squared plus x plus 1. Okay? And if you'll notice, at least I think you'll notice, we worked this problem backward in the last section. So I actually gave you this and asked you to find that. Okay, now we're sort of going backwards. So here's an example. I want you to factor x squared minus 4. Okay, and it is going to be one of those fancy rules that we saw in the last slide. Okay, now I'm going to move on, and we're almost at the end of section R.5, so I'm going to put this all in one little video. So now I want to talk about tougher cases where it's not just a sum or a difference of binomials or trinomials, perfect squares and perfect cubes. Okay, so here we're actually working with trinomials. Okay, and so that is a second degree polynomial. A trinomial is just things that have 3 terms in it. A second degree polynomial is something that has an x squared in it, and that's the highest thing, highest degree that we see. Anyway, if I am interested in factoring ax squared plus bx plus c, okay, where capital A, capital B, and capital C are just numbers, I have a number of steps here that I can follow in order to try to factor this fully. So, our situation is when a is not equal to 1, and a, b, and c have no common factors. Okay, so we're past the first step. Now we just need to get past the second and third and fourth, and so on and so forth step. Okay, so we're going to follow these steps to factor the polynomial 2x squared plus 5x plus 3. Okay. We all know, or most of us have had experience with factoring when a is equal to 1. But now we have the tougher case when a is not equal to 1. And so what we need to do is first find the value of a times c. Okay, where remember a is the coefficient in front of the x squared term, and c is the coefficient that has no x term. Okay, so a times c in our example here is 2 times 3, or 6. Okay, so we need to find ac, that's step 1. Find a pair of integers whose product is ac and adds up to b. Okay, so now we have to have 2 numbers that that multiply to 6 and add to 5. Okay, and so the 2 numbers that we're looking for that multiply to 6 and add to 5 are 2, and 3. Okay, so I have my small a's that they talk about up here in step 2. Small a I'm going to call 2, and small b I'm going to call 3. Because I know 2 plus 3 is 5, and 2 times 3 is 6. So I have things that multiply to 6 and add to 5. Okay? So that's step 2. So step 1 down, step 2 down. Step 3 is to write the original equation in a slightly different format. Okay? And so it's ax squared, for which for me a is 2, plus ax, 2x, plus bx, plus 3x, plus 3. Okay? So, why did I do that? Well, first of all, was it valid? And the answer is yes, it was valid, okay, because I can say 2 plus 3 is 5, okay, and have it as 5x, or I could say 5 is the same as really 2 plus 3 and rewrite 5x as 2x plus 3x. So that was step 3. Now it may have been, you may have said, well, I think that A is 3 and B is 2, and that's okay, because A times B is still 6 and A plus B is still 5 if the items are switched. But it's for this next step that it's sort of important that A is 2 and B is 3. This last expression that we're going to do, so we have this expression, we need to factor this expression by something called grouping. Okay? And grouping is where we have this 4-term thing here. I group the first and the second together. Okay? I look at that first object and I say, what's common to both? And the thing that's common to both of them is 2x. And I'm left over with x plus 1. Okay, great. Plus, what's the common factor of 3x? What's the common term? 3x plus 3. The common factor here is 3. And so I pull that out in front. 3 times x plus 1. Okay? And so now I have an equation, or I have a statement here, where I have x plus 1 here and x plus 1 here. So then I can work the distributive rule backwards again. Okay, pull out the x plus 1 over to the right. So pull that one out and pull that out. And I'm left with 2x plus 3 times x plus 1. And so it turns out that that is the final answer. Okay, and so that's how you group, that's how you factor by group is that last step. And all of these together is how you factor the general form ax squared plus bx plus c. Okay? So the last your turn for section R.5 is this. Here I have a trinomial, or a polynomial with degree 2, to be more specific, with coefficient of 2. Okay, 2x squared minus x minus 6 is what the polynomial is. I want you to factor it using the strategy that we just talked about. Okay, and that's the end of this video.